Elite Squad. Integrated 3, the best working with me is the Elite Squad. Elite Squad. Calculus prep, we're taking the next step, cause it's Elite Squad. Elite Squad. Learning pre-cal, cause it's your best pal. Come on, Elite Squad. Elite Squad. Learning from Wade, cause you wanna have it made. It's the Elite Squad.
Okay, Elite Squad, you are going above and beyond by doing 3 more lessons that we didn't get to. So thank you for your dedication. We are on lesson number 10 that I emailed to you, and we're gonna start with some easy warm-up stuff to jog your memory. Okay, number 1, x cubed equals x times blank. All right, x cubed equals x times x squared, right? Because hidden first power, 1 plus 2, gets you back to 3. All right, you'll need that logic today. Also, square root of 3 over square root of 7. If they're both under a square root, if they're both under the same house, the same roof, then can't we put them all under the same roof? So you can write square root of 3/7. All right? Now, next one. Sine squared plus cosine squared equals blank. We learned this in integrated 3. We're doing it in pre-calculus. It comes back in AP calculus. Again, this is called the Pythagorean identity. A squared plus b squared equals c squared. Do you remember what sine squared plus cosine squared equals from integrated 3 and also from pre-cal discussions? It equals 1. That is a known fact. But the other question, this is what trips up pre-cal students. Does sine cubed plus cosine cubed also equal 1 if they have the same exponent? The Pythagorean theorem only works with squareds, not cubes, not fourths, not fifths. So no, at least not always. In some cases, yes, that could be true if you picked the right x. But is it universally true? No. All right, next memory jog from integrated 3. Sine over cosine is the same thing as, hopefully you said it, tangent. Tangent of x, known fact. Okay, here's something we see that pre-calculus students get tripped up on when you change the powers on them. If you change the powers to 7th and 7th, is sine to the 7th over cosine to the 7th still tangent to the 7th by this rule right here? Okay, well, guess what? In your Pythagorean identity, you can never change the powers. And also because it's addition or subtraction. But if it's multiplication or division, yes, that would be the same thing as this. And here's the connection. If you have the same roof, can't you combine under that roof? If you have 2 things going to the 7th power, can't you just combine them under the same roof? Here's the middle step we're not showing. It's sine over cosine, just like the 3 over 7 earlier. It's sine over cosine under the same roof to the 7th power. Guess what? That's just sine over cosine inside on the base there. Sine over cosine, yes, that is tangent. So the inside gets replaced with tangent to the 7th. So mathematically, that's perfect. So this formula works for all powers right here. And you'll need to know that in calculus. This only works with squareds, all right? All right, let's go to problem A on your page. And well, the board magically erases. This is going to be a straight up pre-calculus problem using the facts we just talked about. So we have prove secant squared of x minus 1 equals tangent squared. This is a pre-calculus fact. This will come back in AP calculus and it will come back in college. So we start with the left side. We start with secant squared minus 1. We keep doing steps until we get it to turn into tangent. This kind of relates to the last lesson, lesson number 9, actually. 1, you can't change 1. 1 is just 1. But you can change secant squared first. What is secant? Secant is 1 over cosine. You remember that one? So what is secant with a squared on it? 1 over cosine squared. Those are the same thing right there. Minus 1. And you can even put an equals right there. So your first step is, oh, secant, you're the reciprocal of cosine. Start with that. Now I want this to look like the answer I'm trying to get to here. So how do I change this into that? Here's what a good pre-calculus student notices. These are two separate terms. Group A, subtraction or addition. Group B, two groups. I am trying to get to one single group. There's only one way in any class from like 5th grade on up to college that you can get two things to go together and become one thing. Common denominator. And I'm going to disguise one. Well, the common denominator, the only denominator, is cosine squared. How do I make it a common denominator? 1 is the same thing as cosine squared over cosine squared. Now you have a common denominator. And now we put the two pieces together. So we get one lump sum to kind of look like this. All right, common denominator stays the same. Keep it. Top, 1 minus cosine squared of x. Now I have one group, and I'm trying to get one group. But somehow this has to turn into tangent squared. All right, let's see how we can do that. Wait a minute. Let's go off to the side here. Remember the Pythagorean identity? Because it's something that you want to identify when you see it in calculus. If we know this from integrated 3 right here, do we know something about 1 minus cosine squared? Let's see. If I subtract cosine squared from both sides, because you can take any formula in math and modify it. As long as you do things to both sides, you can get away with it. Isn't sine squared equivalent to 1 minus cosine squared? This is kind of a spin-off that you also want to know in calculus. It's a spin-off of the Pythagorean identity. All right, so they have like other modified versions. If you ever see 1 minus cosine squared, I want you to recognize, hey, that's actually identical to sine squared. So when I see 1 minus cosine squared in a math class, right away, I change it to sine squared. Over cosine squared, of course. And now we have sine over cosine is tangent. Is sine squared over cosine squared equivalent to tangent squared? Yes, just like the warm-up. Remember 7th power, tangent to the 7th, same thing. So this is equal to tangent squared. Check. So this is like lesson 9. The answer is not just tangent squared. I gave that to you. They'll give it to you. Your answer is showing all your steps to verify you understand pre-calculus. All right, so we're done with that one. Letter B. So there are 3 major trig identities that I want you to know before you walk into calculus. Sine squared plus cosine squared equals 1. We just did that one. Tangent squared equals, we just discovered it. We just proved that it equals secant squared of x minus 1. So that's a new fact. So that's one of the top 3 identities I would definitely want you to know. Now, what if you ever find yourself in a situation where you need to get secant squared and not tangent squared? Can we do a spin-off of this newfound formula? So you'd have this in your head right here. I want to isolate secant squared by itself. If we just didn't have that pesky minus 1, could we just do plus 1 to both sides? I mean, you don't have to write it. You can do it in your head. But matter of fact, I kind of hate to cancel out part of our formula here. But if you add 1 to both sides, isn't secant squared equivalent to, that's gone, tangent squared plus 1. So isn't that also a fact? Okay, so put that in the box right there. Now, do you need to memorize this? No. Just memorize this one. Memorize tangent squared equals secant squared minus 1. And then you can always modify it and resolve it for secant squared if you ever have to, which occasionally you'll have to. Then there's a third major identity in precalculus. Cotangent squared is equal to cosecant squared minus 1. Do you remember that cosecant is the reciprocal of sine and cotangent is the reciprocal of tangent? All right, that's a fact. Now let's say you're faced with a situation where you want to get cosecant squared instead. There it is right there. You've got this formula memorized. You have these three memorized. I want to get cosecant squared by itself. I need to get rid of the minus 1. Couldn't I add 1 to the other side? And it would be cotangent squared plus 1. So put cotangent squared of x plus 1 in that box. All right? So you have the major three identities, and then you can always make your own spin-offs. Now, I'll admit, confession time, when I was in college taking all these high-level calculus classes, I rarely struggled because I'm like freakishly good at math, but there was one thing that it was these identities that I only used like once a year, and I would tend to forget, wait, which one has the subtraction? Does this one have the subtraction and this one has the addition, or this one has the addition and that one has the subtraction? I was always confused about that. And then one day when I was actually teaching it, I had an epiphany. Tangent squared. If you have that rare situation in calculus where you have to rewrite tangent squared as something else, and you're going to memorize this, secant has an S, subtract has an S. Cosecant has an S, subtract has an S. So when you're on the S side, it's subtract 1. Tangent, the T looks like a plus sign. It has a plus 1. Cotangent, the T has a plus sign, or the T looks like a plus sign and has a plus sign, both. So when you're on the T side, it's a plus 1. And then the S side is a minus 1. Now when this comes up again in calculus next year, this fall, hopefully you'll see that and say, wait a minute, I remember Mr. Wade teaching me this on video on YouTube during the COVID-19 outbreak, and it's jogging my memory, so you'll remember it when I mention it again, all right? So that's how you keep all this stuff straight, a little mnemonic device for you. All right, let's go to the next question, letter C. Rewrite tangent cubed of x times secant to the fourth of x, but you can only write it with a single tangent term, which it does currently have just a single tangent, but it can be no higher than the first degree. All right, so here's what you face in calculus. Here's your first test, kids. All right, here's the scoop, kids, as Mr. Wade says in class. Tangent cubed. I want just a single tangent to the first is kind of the goal here. So let me write that first. Tangent to the first, or just tangent, right? That is tangent to the first. There's a secret 1 right there. All right. But what else do I write? Wait a minute. In the warm-up, we said that x cubed was the same thing as x times x squared. Guess what tangent cubed is? It's tangent times tangent squared. That is mathematically correct based on our warm-up question. All right? And then the secant to the fourth just drops down here. So now you split your tangent up. So what did we accomplish? We got a tangent to the first power because we actually have to try to get a tangent to the first degree. We did it. Now here's the second catch. We got the first degree there. We don't have a single tangent term anymore. We have 2 tangent terms. So, which tangent do we keep and which one do we try to change? Keep this one because we have to have tangent to the first as a stipulation here. So this one's good. We wrote that one on purpose first because we wanted that one. So we need to get rid of the tangent squared. Keep the tangent of x. Get rid of the tangent squared and make it not a tangent. Is there anything else that tangent squared is equivalent to? Wait a minute. The last problem we just did. One of the 3 major formulas in precalculus, major identities. Tangent squared can always be replaced by secant squared subtract 1. Remember the S sound? So we play the game, tangent of x, you're good. When any good pre-calculus student sees tangent squared, they remember that it's secant squared of x minus 1. In parentheses, any good math student at any level of math remembers that part. You gotta put your parentheses. Secant to the fourth, we're just gonna drop you down here. Okay? And now you're ready for your last step. I just want to clean this up a little bit. Did we get a single tangent term? Done. Is it to the first degree? Yes. And everybody else in the problem is, guess what? Not tangent. That's all that matters, is that everybody else is not tangent. One more thing I would ask you to do. Keep this guy right here. That's what we wanted. I'm going to put a bigger parentheses. Can't we use the distributive property? So what's secant to the fourth times secant squared? Isn't that the same as x to the fourth times x squared? Same base, add the powers. It works in trigonometry as well. Secant to the fourth times secant to the second is secant to the 2 plus 4, which is 6. Secant to the sixth of x. Yes, you are allowed to do that. And then secant to the fourth times minus 1 would just be negative 1 secant to the fourth, drop the 1. And you've got an answer that has a single tangent to the first power. So it's just kind of knowing your identities. In calculus, we're going to play this game right here. And then we're going to have like 2 additional steps to get to a different kind of answer we're looking for. But that thing in calculus is impossible unless you realize that tangent cubed splits and that tangent squared has a special identity. If you can remember that in calculus, you'll be able to do the rest of it that I teach everybody next year. So rewrite cotangent to the 6th power. That's kind of a weird one. And you have to get a single cotangent term, which we technically have right now, but you can't have a power higher than the 2nd degree on your cotangent. All right, again, can a good pre-calculus or calculus student find their way through the algebra so that then they can focus on the calculus? So, first thing, no powers higher than the 2nd degree on your cotangent. So I'm going to write cotangent squared of x first because I want to make the maximum 2. I don't want cotangent cubed. I don't want cotangent to the 4th, 5th, 6th. I want it to the 2 at the highest. What's left over? Cotangent squared times blank is cotangent to the 6th. 2 plus blank is 6. 2 plus 4 is 6. Isn't that just like x squared times x to the 4th equals x to the 6th? Except it's with cotangents. So we split. That's allowed. Now, here's a problem. The first term is okay because its maximum degree is 2. This is way too high. I can't have a cotangent higher than a 2nd degree, it says, to play this game. It's just a game is all it is. So I need to split this one into cotangent squared times what? Cotangent squared. Why? Because 2 plus 2 is 4, so that's mathematically correct. Now, you're all clever. You're all doing this extra pre-cal stuff because you're trying to get ahead. So you're all very smart. A very, very advanced pre-cal and calculus student, like some of you, probably all of you, will skip this step and you'll go straight from 6 equals 2 plus 2 plus 2. So you'll save yourself a step, all right? Because we know that 6th power is made up of squared times squared times squared, just like x squared times x squared times x squared is x to the 6th. So you can immediately go to this step and have no powers higher than 2. Great. All right, I'm going to keep the first term. Cotangent squared, you're good. I want a single cotangent term that is the 2nd degree at the most. So you're fine. I need to get rid of that. I need to get rid of that. Those are not good. I want this to be the only cotangent in the problem. You got to be something else. So you'll have these situations in calculus where you're trying to convert something to something else. I've got cotangent squared. I want it to be something else. Is there anything that cotangent squared equals? Remember the previous problem? We're back up there in letter C. cotangent squared can always be replaced by cosecant squared minus 1. Secant s subtract 1. And this cotangent squared, can't it also be replaced by cosecant squared of x minus 1, because it's a mathematical fact we talked about today. Did I get a single cotangent term and everybody else to not be cotangent? Yes. Accomplished. Is the highest degree the second? Yes. That's why we had to break it down into these smaller degrees. Convert, convert, keep. And then this isn't bad. This is actually pretty good for calculus right here. I would go ahead and encourage you on the homework to practice this one extra step. How in a math class do you multiply 2 terms times 2 terms? It's our old favorite acronym called FOIL. Remember this? First, cosecant squared times cosecant squared is just like x squared times x squared. 2 plus 2, 4. Cosecant to the 4th of x. Outer, cosecant squared times negative 1. Negative cosecant squared of x. Let's move that parentheses. All right, make some space here. First, outer, inner. Negative 1 times cosecant squared. Negative cosecant squared of x. And last, negative 1 times negative 1 plus 1 close parentheses. So remember how to FOIL. And then I guess there's one more thing I would probably do. Final answer, cotangent squared times cosecant to the 4th of x minus, now, I lost 1 cosecant squared minus 1 more cosecant squared. Remember in class, if I lost a cat and I lost 1 more cat, didn't I just lose 2 cats? Darn coyotes in the backyard again. And then plus 1. So collect your like terms always, right? And there's your final answer. Does it contain cotangent only once? Yes, only once is there a cotangent. These aren't cotangents. Is the highest degree the second degree? Yep. So this lesson is all about just being creative, using your 3 identities that we outlined there in letter B. I think I said C earlier, darn it. In letter B, and being able to just do algebra, basic algebra, all right? So it looks complicated, but it's based on what you've learned before. Now try the homework and see if you can master this topic.